Howdy folks, Mr. Reed here, and welcome to one more question. So I'm going to be taking a look at another factoring of a trinomial with a lead coefficient, actually the same example as last time, but I'm going to do this one using a decomposition method. So if you want to see something that's a little more step-by-step approach, and if this thing actually is factorable, it will get us to an answer a little more it's not that the other one won't get you an answer consistently, but the process will be more consistent. So if you want to see a more step-by-step approach to factoring a trinomial, you're in the right place, so let's get to it. Alright, so I'm going to use the exact same one as last time. So 2x squared minus x minus 10. Now, this time, I'm going to play a little game where I take these two values, multiply them together to get negative 20, and this value, which is actually a negative 1, and I'm going to come up with two numbers that when you multiply them together gives you negative 20, and when you add them together, it gives you positive 1. Sometimes with my students, I'll set this up in a little x where I'm saying, okay, well, I'm going to make sure that they multiply, give me negative 20, add to give me negative 1. What two numbers will do that? Well, 4 and 5 will do the 20, and they're also 1 apart, so that bodes well. I'm going to put negative 5 and positive 4. That adds to give you negative 1, multiplies to give you negative 20, so that's good. So again, over here I would have filled in negative 5 and 4, negative 5 and 4, but it doesn't really matter how you set it up visually, it's just that you find those two numbers. Now what we're going to do is we're actually going to rewrite the original statement, but we're going to do a decomposition. We're going to take that middle term and we're going to write it as two separate terms instead. So those two separate terms are going to have the negative 5 in it, so negative 5x, as well as the positive 4. Those two values are found specifically from the number game that I was playing earlier, where I was looking for two numbers that multiply to give me the coefficient on the front and the constant at the end multiplied together. So that negative 20 looked to have those two numbers multiply to give you negative 20 and add to give you the coefficient on the middle term, which was negative 1. All right, so we're going to continue on here, and that's still minus 10 at the end of that thing. And now I am going to do a common factoring of two pairs here. So I'm basically going to say binomial number 1, binomial number 2. Let's do a factoring of that. So the first one has 2 and 5 as coefficients. There's no number that is a common factor there. So I'm just going to have x shared between them. So that's going to give me 2x minus 5 left over. And I have for my next one, I actually have 2 will be a common factor. There's no x that's shared between them or amount of x's. So I'm going to have 2x minus 5. Now, at this stage, if everything's worked out well, you'll notice that this common factor of the two pieces separately actually creates an overall common factor for the whole thing altogether. So I'm actually going to take that common factor and pull it out to the very front of my expression as a common factor the way I normally would find common factors. What am I left with? Because that's the stuff that's going to be written behind. Well, it's going to be this divided by the bracket, which just leaves me with x, and then this one divided by the bracket, which just leaves me with plus 2. So I would have, basically, I call them usually the leftovers. Those leftovers would go into that position and this position, and it gives me my final answer. So what we're doing here is we're kind of playing this little number game, breaking down the middle term into two pieces instead of the old one piece, using common factoring to pull out the greatest common factor out of the first two terms, the greatest common factor out of the second two terms. Now, one of the things you might ask is, does the order of some of this stuff matter? So for instance, right here on this line, does it matter if I write the negative 5 or the 4 first? No. It might make the mid steps look different, but it won't change your answer. And then, here, does it matter if you write the order? No. Things multiplied one way or the other way are the same, so everything else is pretty self-explanatory as to why it would be okay. But you don't even have to worry about which number goes where out of the two of them when you do the decomposition step in the middle. So if I wanted to double check this, I would do probably distributive property and say 2x times x is 2x squared. 2x times 2 is going to give me plus 4x. Minus 5 times x is going to give me negative 5x, and then negative 5 times 2 is going to give me negative 10. All right, so we're going to get 2x squared minus x minus 10, which is good because that's what we started with. So this appears like it worked. It is going to be a very consistent method as long as this thing is nicely factorable. Of course, there are non-nice factoring examples that do actually factor but are not nice roots. And there are also ones that aren't going to be factorable at all. But for this method, it's going to work really well when you have nice integer roots, and so a lot of your examples, at least for the stuff that I teach this with, are going to be that way. So hopefully you found that helpful. If you did, like, subscribe, and as always, take care, folks.